Please note. Copyright notice. This material is copyrighted 2024. In all forms of text and media delivery. No artificial intelligence use whatsoever granted. Please refer to the author for all permissions. A deeper view of reality and life, with quanto-geometric number theory. This study will initially acquaint you with quanto-geometric theory, or QGT. Its goal is to examine or re-examine the foundations of number theory in a new practical light. Number theory in general can be viewed as the beginning of mathematical physics, although mathematical physics is generally grandfathered by a more sophisticated form of mathematics. Understand the term mathematical physics as a reflection of the fact that everything in existence in the reality of this world is embedded in mathematical categories. Meaning that mathematics is interwoven in the state and expression of everything in existence. You have to understand math in some fashion in order to understand physical reality in ways that empower you to manipulate the world. That is as true as putting money in the bank, or counting the amount of money you have at the bank. Section 1. Reality is embedded inside the abstract world of numbers. What we are going to do, in this introductory series, is to study that special form of number theory, which will lay the groundwork to understand the foundational elements of physical reality as a whole, and how events of any class occur in reality and individual lives as well. But please don't get scared or intimidated, just because it's math. If there is one thing that our schools can be blamed for, in my opinion, it is to have turned the study of mathematics into the nicest nightmare for every living soul, partly because Western mathematicians always wanted to be a select class or caste, with an edge on the rest of human mortals. But this study of numbers is going to be just fun, at least intriguing. Most of all, enlightening. I promise you that it's going to be something you've never seen before, even for those who are acquainted with traditional number theory in math. Yet, this study is going to be totally accessible to most of you, simply because most have gone to elementary or primary school, and have learned elementary math. That is where it starts, and that's all it's going to take as a prerequisite, just elementary math. I'm going to show you another fun and unusual facet of numbers. And by visiting numbers in that particular manner, you are going to uncover a different facet of reality, as well as the unfolding of your life, which will all reveal themselves to you under a whole different light. Let me start by asking you this question. Suppose that, in an otherwise empty room, there is 8 chairs. You look at the chairs, and you count them. The question is, can you separate 8, as a count or quantity, from the chairs? What an unusual question, isn't it? I know what your answer is, no, you cannot separate the number 8 from the chairs. But let's say that somebody intentionally put these 8 chairs in the middle of the room. So, the person had to mentalize the count of 8 for the chairs, and then subsequently brought the chairs into the room, in the count of 8. Is it then not fair to say that number 8, in this instance, existed before and separate from the chairs? That is particularly even more true, if the person had to build the chairs. If he had to build the 8 chairs, then 8 would have absolutely existed, before the chairs could come into existence, per the person's work of fabrication. So, 8 existed as an abstract entity before it could be materialized in the chairs. Did it not? If 8 had vanished from the person's mind, say that he or she went blank for a few minutes as we say, or for the duration, he or she would not have been able to compose the ontology of a group of chairs, because he or she would not know how to compose the group ontology centered on 8, which would lead to the event of bringing the 8-chair assembly, matter-of-factly, in existence in the room. And what is ontology again? Just another big word for existence, or things in existence, only as a reminder. I want you to take a few seconds to think about this. Think about the notions of before and separate. Numbers exist independently from the material world, even though they are abstract or immaterial for us, and further they have a life of their own. They don't need us to think about them, in order to exist in abstraction. They inform every single thing in existence, independently of the representational or mental capacity of living beings. So, numbers exist in their own abstract world, and the world that we observe, exists through them. Is it not true that every single thing has an internal elemental count in composition, along many different structural lines, and an external inventory count as well, as relates to participation in groups? Take for instance, flowers in a beautiful blooming rose shrub. You will find in a rose bloom from a commercial outfit, from 20 to 40 petals. In a rose shrub, there will be any number of blooms that you can count, usually anywhere from 100 to 200. So, the order of cardinality, as we say in formal mathematics, to mean the count of things, does subsume all elements of reality in an intrinsic manner. Another way to think of this is that, observable reality exists, by embedding inside the abstract world of numbers. You cannot see the numbers in their individuality, but they are everywhere, ubiquitous, and inside everything as ever. Furthermore, there isn't 2 or 3 or 10 different ways of thinking of any number, as though that depended on who is doing the thinking. We all think of the identity of any number or quantity, in the absolute exact same way. And it's not because we've all been taught in the same learning system. Numbers have been the same in the Hindu culture, as they were in the Arabic culture, which are obviously two quite different cultures. And before the Arabic culture, ancient Egyptians manipulated numbers in a high degree as well. And that is how famed mathematician Fibonacci in the West, had been able to make a merge of what was known about them, both in the Arabic and Hindu cultures. Even across living species, the identity of numbers remains the same. For instance, we know that dolphins, who can do math, as clearly evidenced by conclusive experiments, think of numbers the same way as humans do. So, numbers appear to us and all other forms of the living, in the same identity, because that identity is proper and unique to them. They exist in their own right, independent of their materialization in the physical world, whether you want to qualify that existence abstract or not. One reason why that is so, is because we infer, or figure numbers, from the notion of quantity, the quantities that are inherent to the elements of reality. We are going to see, however, that there is a whole lot more to numbers than just quantity. Section 2. Numbers have a signature, which encapsulates their identities and behaviors. This is an unsuspected reality about numbers, because thus far in human culture, we only pay attention to integers, or the integer part of numbers, and largely neglect the decimal part. The decimal part always exists, even when it is 0, which would be expressed as 0.0, if it were not always kept under omission. We are much in the habit of rounding off decimals to just a few digits whenever they exist, commonly 2, because we think they are insignificant to magnitudes. Magnitudes are the only properties of numbers that we generally care about. Nonetheless, decimals are an important part of numbers, which can get us acquainted to their true signatures. Consider the number phi, from the golden ratio. We will discuss later the origins of the golden ratio in details. This number is a historically famous mathematical quantity. Many mathematicians have even seen in it something mysterious and divine. For now, if you want to generate the number phi by yourself, its formula is square root of 5 plus 1 altogether divided by 2. We are going to dive into the study of this number, for its very practical applicability, and the principles it elicits, as relates to this new number theory vision. The symbol of the number phi will be at the top of every one of the supporting illustrations for this tutorial. We are going to use 13 specific illustrations to underwrite this material. They are indexed from A to M. We will call them Board A, Board B, Board C, etc. It is important to pay the greatest attention to these illustrative portrayals. Please pay particular attention to the color coding that underscores the numeric categories examined in the presentation. If necessary, pause the flow of the presentation to absorb as much as possible the information presented in these 13 illustrative boards. This is one of the times when visuals do matter, and as the saying goes, an image is really worth 1,000 words. We start by presenting the phi number on board A, as it derives from the golden ratio. It reads: Are you ready? 1.61803398874989482030917720300917920309179805762862135448. Oof. A suite of 61 digits. So, I have presented the number here with a total of 60 decimal places. That's a little funny, isn't it? I am sure that's the first time you've seen so many numbers together. You would be surprised though, the staggering amount of significant artifacts or structured information there is interspersed in this suite of decimal places, which we've been missing for thousands of years. So let's take some time to analyze this number, shall we? On board A, the first block in yellow shows us what we call the first decimal section of the number. What follows in blue in the second yellow block, as indicated by the arrows, is the second decimal section. In traditional number theory we don't make those distinctions, but here that is very important. You will later see that this segmentation is not an arbitrary election. On board B, in the 31 decimal figures presented in the first decimal block, there is 9 times the number 8, and it's the largest recurrence of any digit in the decimal segment, as you can see for yourself. In further analyzing the first decimal block, if we stop the decimal at the third figure, the number would be 1.61, as highlighted on board B. By doing an immersive summation between these starting 3 numbers, we would obtain again the number 8. Number 8 reappears in that way in an implicit fashion. The recurrence of number 8 in the entire expression is the most nuclear characteristic of the phi number. You can take some time to count yourself the number of times number 8 recurs in that decimal section. I have represented them in red. With the immersive repetition, it appears a total of 10 times. On board C, notice now that the fourth digit after the starting group of numbers 1.61, an immersive 8 figure, the next digit is interestingly the very number 8 in an explicit manner. So that would make for a figuration of 88. The first 8 is depicted in purple, to express that it is immersive. 88. Even more interestingly, the exact and explicit numeric figure of 88, does also appear in the fuller decimal, just 4 digits after the immersive 8 figure. That is well depicted on board C. At the end, the recurrence of number 8 is amplified by the numeric representation of double-digit 88. 88. 88. This feature puts in high emphasis the nuclear number 8, and doing so in a doublet repetitive manner. Therefore, we can safely say that there is here a doublet recurrence of number 8 in the 88 figuration, and separately a double recurrence of number 88 itself, which further augments the recurrence state being developed in the decimal. That amplification overall goes from unity, in single digit 8, to double, in the juxtaposition or pair 88, to triple, in the repeat of the pair 88. Please take some time to revisit this categorization, and make sure it's sunk in. Next, notice that there is a segment in the fuller decimal that stretches between two zeros, indicating a cycle. That is highlighted on board D. 0339, 887, 4989 48 48 2. The cycle starts with the first zero in this decimal segment, ending with the digit before the last zero, which is 2. Take the last zero as the start of a new cycle. Now, counting the number of digits from 0 to 2, we find that there are 16 digits, which equates 8 plus 8, and most significantly casting again the 88 figuration. This categorization shows us that the decimalization is being developed in a cyclic manner, and in a way that is relevant to the nuclear number 8. It also underscores that nothing is occurring in a random manner inside the number, but always in an orderly functional manner. On board E, highlighted are the numbers 33, 88, 48 48. First, notice that 48 is a multiple of the nuclear number 8, 48 equals 6 times 8, and 88 is of course a multiple of 8 as well, since 11 times 8 equals 88. There are two more particularities about the number 4 appearing in 48, in the numeric context of the number phi. First, number 4 is not only a dividend of nuclear 8, but it further, equally divides 8, or divides it in two equal halves. Therefore, through the number 4 figuration, number 8 reappears in a very meaningful manner here, by what is called demediation, as a semblance or half-semblance if you will, of 8. We will talk about demediation later, when discussing another expression of the decimal. More importantly, the mentioned suite of numbers showcases a doublet repetition, or an amplified doublet state. The first doublet, 33, is established on the basis of one number, number 3. The second doublet is also established on the basis of one number, but a larger one, the very number 8, casting the double-digit number 88. And the third doublet, 48 48, is established on the basis of two digits or the 48 pair, and further represents a larger number than the previous 88. So, number 33 is a two-digit state. Number 88 is still a two-digit state, but a larger number. And number 4848, an even much larger number, is a double-digit doublet. Therefore, here we see that recurrence takes an increasingly amplified value, up to the compounded doublet state. On board F, we have the suite of numbers 33, 34 36, 38. Representing a sequence. The innate structure of the suite, which is a Fibonacci sequence, is not directly observable. We have to do some digging, to uncover the Fibonacci identity. Between the suite of numbers, we have at base the sequence, 1, 2, and 2, since reading backward, difference between 38 and 36 is 2, difference between 36 and 34 is 2, and difference between 34 and 33 is 1. The suite in 1, 2, 2 is a known legitimate sequence. To continue the progression after the third digit of that sequence, we apply the rule, product of two prior numbers. 1, 2, 2, 4, 8, 32. This is a higher order Fibonacci sequence. From there, we can look for the base Fibonacci sequence, for a reconciliation. To do so, we use the power operator over the number 2. We then obtain the expression 2 to the power of 0, 2 to the power of 1, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 5. Where 2 is elevated to a suite of powers, which will make each number here equal to its equivalent in the prior sequence. Take some time to verify those equalities with a calculator. So, the complete primal Fibonacci sequence in the suite of powers of 2, is the inner truth, or truth table, of the prior sequence. It is the primal Fibonacci sequence, where the rule is to make each number the sum of the two prior ones. In that manner, we have recovered the primal Fibonacci sequence, 0, 1, 1, 2, 3, and 5, from the sequence in bright yellow, thereby showing that it is innerly driven by the base Fibonacci sequence. On board G, two things are immediately visible to the mathematician, after extracting the expression in bright yellow from the phi number. One is the Fibonacci sequence, or the beginning of that sequence. 48, 48. 58, 68. We have evoked previously the primal Fibonacci sequence. We call it primal because it is the most primordial Fibonacci sequence that exists, which is the tightest one established on the base numbers in the decimal number system, sequence 0, 1, 1, 2, 3, 5. The suite of numbers in bright yellow in G, is a higher order Fibonacci sequence. Effectively, from 48 to 48 there is zero progression. From 48 to 58, the reason of the progression is 10. And the reason of the progression is again 10, from 58 to 68. Thus, the suite yields a progression of 0, 10, and 10, which is a higher order Fibonacci sequence. Accordingly, the next number would have been an addendum of 20, to follow the rule for the reason in the Fibonacci sequence, that is, 0, 10, 10, and 20. That would have unsurprisingly yielded the number 88 to follow 68, by correspondence. In order to recover from here the primal base Fibonacci sequence, we simply have to divide by 10, each term in the sequence, 0, 10, 10, and 20. This division yields the exact terms of the primal sequence, 0, 1, 1, and 2. Of course, 88 exists in the decimal string, but before the noted sequence, as you may verify in the very first yellow block of decimals. In order to join 88 to the sequence, we would have to create a revolution inside the string, yielding a nonlinear structure in the continuum. This form of symbolic movement we will see in a more developed manner in the next recurrence state. The next three characterizations for this decimal segment in the phi number, are tantamount to clear geometric figurations, principally the palindromic figuration. In a palindrome, you generally have an odd sum number, with one central digit with two identical flanks at each side, so that the number reads the same, both forward and backward. One example of such number is displayed on board H, the number 989. The number portrays 3 digits in total, and is centered around digit 8 with digits 9 at the flanks. Read the number forward or backward, it will still spell 989. The accompanying number 988 is only an approximation to a palindrome. The only aspects that will remain the same in forward and backward read, are the number 8 at center and the pair 88. But if you should juxtapose both numbers to one another as in 988,989, you get to approximate a tighter form of palindrome, as shown on the I board. Read the numbers in groups of 2 or pairs, the backward reading would be 989,889. It is an interesting quasi-palindromic state, that is based on paired digits or two-digit numbers, instead of single digits. You ought to fix the two central digits, as though they were surrogating a single-digit state, for the full number to be consistent with the palindromic portrayal. And you can clearly see that the flank numbers 98 and 89, do not change in both forward and backward reads. Non-trivially, there is also the meta feature, that the digits at the palindromic center, are not only the same as in the flanks of the quasi-palindrome, but also inverse figurates of one another as a two-digit number. Finally, on board J, notice very significantly, that if you should consider a three-digit number, making up the center of the quasi-palindrome, that is 988,989 and 989,889. What you will get is a shifted form of palindromic state, with 898 as a straight read within both numbers, for a palindromic center. At the flanks, reading the numbers or digits individually, you get the reading of 9, 8, and 9, portraying a single-digit ordered suite, which reads the same in both cases. Please stay on this for a few minutes to make sure you get it. At the same time, nature is teaching us here, the true meaning in the geometric organization of a numeric palindrome. Although appearing a bit irregular, this is in fact an authentic palindrome, which we have dubbed a shifted palindrome. On board K, the suite of decimals presents, with a complex or composite form of odd parity with three levels of expression. At the center of this complex palindrome, number 7, an odd number. And at the flanks, we get two five-digit or odd expressions with palindromic-like structures as well. 33,988. 7. 49,894. With digit 8 at the palindromic center, the expression 49,894 is itself fully palindromic, as shown on board L, as it reads exactly the same forward as it does backward. In the expression 33,988 on board K, 9 is the palindromic center, and you get two doublets at the flanks. The doublet nature of the flanks is what is going to act for the flanks to construe a palindromic state, should you want to express the similarity in palindromic term. We have termed this form of expression a reduced palindrome. The doublet nature is conserved when you flip the number around center 9. So, in total, expression 33,988 is, at the outset, a palindromic surrogation. When you consider the entire expression in its three separate components, and according to the above definitions, it may be categorized as a complex palindromic state within a larger dimension. More appropriately, what is being portrayed here globally, is a larger odd parity state, with three levels of expression. We have 5 digits, an odd number of digits, at each side of number 7, again an odd number, as a center, and all making up a paired figuration or configuration. Each side has a different form of recurrence than the other, one is full or proper palindromic recurrence, and the other is based on doublet latent palindromic recurrence. So therefore, in summary, we have here a combination of parity state, and odd state. Consequently, we rightly term this state, a composite odd parity state, which of course, supersedes the palindromic state in comparison. With the numbers on board L, we complete the analysis by taking into account all the numbers portrayed in this decimal segment of the phi number. The three separate numbers in highlight, spanning across most of this decimal segment, display an even higher form of composite odd parity. Indeed, it is a qualified expression beyond that state. The three numbers are 74, 204, and 56. The categorization depicted by these numbers, within the decimal segment, construes a major form of geometric symmetry, which is the pillar of what we have come to know as analytic geometry. This pivotal element is the algebraic real number line. It is represented in the Cartesian coordinate system by the familiar x-axis. First, let's discuss the real number line. It is primarily based on what is designated in traditional number theory, demediation. Etymologically, the term demediation can be broken into de or die, meaning two, and mediation, meaning mid or middle. So therefore, the term demediation means breaking in equal halves. In physics, we have the related term chirality, which means laterality or opposite sides. So, we now have a geometric state that we might qualify as a state of chiral demediation, in the algebraic real number line. I have depicted on the green portion of the illustration, the real number line. It features two sections, one that is ordinarily called the positive number line, which is right chiral, going from 0 to infinity, and the other, ordinarily called the negative number line, which is left chiral, going from 0 to minus infinity. Both segments of the number line are equal to one another, and symmetrically normed in tallies or unit counts. For example, there is metric symmetry between +8 and -8. The representation in the three numbers in highlight here, depicts this entire categorization. First, notice that the very center of the entire expression, as shown on the first block in bright yellow, is fittingly the number 0, which is of course the neutral or hybrid number at center of the real number line. 0 appears in the number 204, at mid-position both within the number and the expression in highlight itself. So, it is here, precisely at the center of the horizontal demediate line. The demediate line is the line between 74 and 56 in the illustration in the mentioned bright yellow box. Second, notice very significantly that, there is 7 digits within the decimal between 74 and 204, whereas there is 8 digits between 204 and 56. You can count the spacing digits yourself, in the light yellow box at the top. To see how the number of spacing digits, 7 and 8, is relevant to this geometric characterization, suffice it to realize that as multiplicands, 7 times 8 gives you the number at the right chiral end of the demediate line, precisely 56. Therefore, the metric in the spacing digits, is a forceful harbinger of the demedian state, in the algebraic number line. Third, number 4, as a demediate of the nuclear number 8, is non-trivially part of all three components of the expression. Number 4 explicitly appears in number 204, and 74. It implicitly appears in 56 as one of its dividends, that is 4 times 14, which is equal to 56. See the notations on top of number 56 in the first bright yellow box. In the expression 4 times 14, number 4 interestingly is further emphasized by repeat. Also notice that while 4 is the demedian of 8, 7 is the demedian of 14 as represented there. This further underscores the demedian state in development here. For more recurrence characterizations, let us now further decompose the three individual numbers in highlight, with the use of multiplicands and the multiplication operator. That yields the expression 74 times 1. 204, and 2 times 7 times 4. As shown in the second yellow block. We have added the times 1 multiplicand, to the number 74, under which it remains quantitatively unchanged, and we have decomposed the multiple 56 into its dividends, 2, 7, and 4. So, 2 times here is the multiplicand operator notation, which is the counterpart of times 1, at the opposite side. Both the 74 and 7 times 4 figurations, at left and right, respectively, are symmetric as to the digits and their positions. Yet they differ in that, one is a number entity, and the other a multiplicand operation between two numbers. They further differ in the value of their accompanying multiplicand operators, times 1, and 2 times, respectively. Lastly, they are chiral as to their laterality inside the complete expression, one is left chiral and the other right chiral, giving thereby an even larger representation of the chirality of the expression. So, the left side of the expression with the number 7, an odd number, for the spacing, joined to number 7 within the 74 entity itself, altogether with number 1, also an odd number for the multiplicand operator, altogether prevalently spell, an odd attribute for the left chiral section of the expression. Whereas at the opposite side, the number 8, an even number for the spacing, at the same time a dividend of the even number 56, altogether with number 2, an even number as well in the multiplicand operator, altogether clearly spell an even attribute, for the right chiral section of the expression. The two sides show thereby differing or opposing attributes. So, there you have the antiparity or anti-symmetry portrayal, which springs out in what analytic geometry depicts, as the right chiral positive number line and the left chiral negative number line, representing the two segments of the real number line. There is no question that, the whole extracted expression from the decimal segment, is expressly a representation of chiral demediation, as a major form of geometric symmetry. Discussion. Fair to say that, those are not just characterizations in the structure of the phi number, but they represent things that are happening inside the number, beyond the single value of pure magnitude. These things occurring within the number, which you might call structural behavior, proceed from the identity of the number, and according to different methodologies. They crystallize the eponymous Platonic essence of numbers, and confer to each of them, their signature. You might wonder, how is it possible, that a number is able to develop all these internal geometric properties, while at the same time able to keep throughout, its magnitude discipline? A totally legitimate question. You have to go back to the origin of the number, from where it derived its identity, for an answer to this question. Realize that, the geometric identity of a number, is what constrains its internal geometric properties and attributes. These properties must be realized, just as the magnitude or scalar properties must be realized. So, the scalar properties and the geometric properties proceed in combination, or in correlation, with one another. In this regard, it is opportune to stress, that the signature of a number, spans across both its integer part, and its decimal part whenever it exists. Notice how in the phi number, the nuclear expression of number 8, its root identity, mixes the integer part which is the first number 1, and the decimal part, 0.61, to construe the immersive number 8, as represented in purple at the beginning. Portending thereby to present it, right in front of the following 8 number, to further portray the doublet 88, etc. There is nothing random or trivial in the entire figuration of any number, and God only knows how many trivia we have identified over the years, in traditional number theory. Once you find a count in physical reality, emanating from whether an object composition, a circumstance, or an event, matching one of these demarcated patterns or attributes, then you have found a stamp for the original entity, which will empower you to predict the rest of its structure or behavior, or ontological type. When you look at the suite of numbers or digits in the number phi, it sure looks at first like a chaotic suite of numbers, just as when you look at your life, or the train of circumstances and events in your life. Those seem to be just as equally random or chaotic, don't they? But, did you know or notice already the insistently recurrent composite number in your life, the one that popular wisdom calls your lucky number? Or that other one which might in fact be your nuclear number? What can you unfold from your lucky number, towards the sea of hidden quanto-geometric categories, which interweave your personal means and ways, and your own circumstances of life, just like in the phi number? What's more, it is precisely because of our ignorance of these quanto-geometric categorizations, innate to numbers, that we do not ascertain the unfolding of our lives, since those are the very fabrics obtending our lives. These quanto-geometric categorizations permeate all lives, and reveal the terms of the original instantiation or fashioning of all individual lives, that mysterious thing which we colloquially call the meaning of life, for each of us. That went for everyone. For mathematicians, physicists, and engineers in particular, it will not be difficult to realize the analytic power unleashed by QG number theory. Very particularly, toward the long-standing problem of how to approach very large numbers in mathematics, for example, factorization of large numbers, which is nowadays a focus of quantum encryption technology. Take the above presentation as a quanto-geometric model of how to resolve segmental magnitudes of any breadth in the scalar order, from conspicuous geometric pathways, keeping in mind that all number magnitudes derive from the very specific figuration of composing numbers. In the next lesson, we will see how this entire representation develops an evolving categorization of forms of symmetry. If you find this QG perspective novel, eye-opening or perhaps intriguing, and would like to engage along the path of that new vision to learn more, please subscribe to my channel. I offer systematic tutorials with drill questionnaires, and other materials, to strengthen your learning experience of this novel form of mathematical physics. You will also obtain the questionnaire for this tutorial when you subscribe. Here, you will be learning something not only new and unmatched about the world, but also about yourself, your personal life and its particular circumstances. That, in a formal and systematic manner. Please give this video a thumbs up if you liked it. Thank you very much.